Okay, let's solve a related rates problem. I recommend the following 7-step process for approaching any related rates problem. Step 1 is to read the problem carefully. So the altitude of a triangle is increasing at a rate of 1. By the way, units don't matter in calculus, so I'll be ignoring them for the rest of this problem. While the area of the triangle is increasing at a rate of 2. At what rate is the base of the triangle changing when the altitude is 20 and the area is 110? Now we have an idea of what's going on. In step 2, let's draw a picture. These help us visualize what's going on. The type of picture you draw really depends on the problem. Usually it's some sort of geometric figure. In this case, I hope it's clear that the thing we're going to be drawing is a triangle. In step 3, what you want to do with that figure is identify the variables and constants. So what I mean by that is you go through the problem again and identify the things that are changing and the things that aren't. We're told that the altitude of the triangle is increasing. So another word for altitude is height. The height is increasing. That's our first variable. I'll call it h. And since it's increasing at a rate of 1, that tells us that the HET is 1. So h is a function of time, and 1 is a constant. The HET is one of those constants. While the area of the triangle is also increasing, so I'll call it A for area. That's another one of our variables at a rate of 2, and that tells us the ADT is equal to 2. At what rate is the base of the triangle changing? So the base of the triangle is also changing. I'll call it B. That's our third variable. And since we want to know its rate of change, the question is asking us to find dB dt. Now we want to find dB dt when the altitude, so h, is equal to 20, and the area, which is A, is equal to 110. In step 4, we want to set up equation, possibly more than one equation, and then rearrange. The type of equation really depends on the kind of problem. Usually it's some sort of geometric formula or SOHCAHTOA. I hope it's clear that in this case we want the area for the formula, or the formula for the area of a triangle. So A equals 1/2 base times height. And what I mean by rearrange, if you had more than one equation, you might solve for a variable in one of those equations and plug it into the other one. In this case, since the question is asking for something about the base, I think it would be wise to solve for b in this equation. So multiply by 2 and divide by h, you get b is equal to 2a over h. In step 5, we're going to take that equation and take the derivative of both sides with respect to t. And that just means t is the independent variable, so you do d over dt of both sides. Now on the left, this is just going to end up being dB dt, but on the right, this is a quotient rule. It's a function of t divided by another function. Here's the quotient rule, just as reference, however you want to remember it, it's up to you. But basically, it just says that you do the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Now to finish step 5, we actually need to take these two derivatives. This one's just going to be dHdt, but this one, since it's multiplied by 2 with derivatives, you can just bring the 2 to the front, and you get dB dt is 2 dA dt times h minus 2a times the hgt over h squared. In step 6, plug in, solve, evaluate. So take all of those values from step 3 and plug them into this equation here. 2 dA dt is 2, h is going to be 20, minus 2, and then a is 110, the hgt is 1, and then h again is 20, so we get all of this divided by 20 squared. Then you solve for the thing you're actually trying to find. Luckily, we had the wisdom from earlier to solve for b before differentiation, so we've already solved for the thing we're trying to find, and then evaluate. So we just got to simplify this. 2 times 2 times 20 is 80, minus 2 times 110 times 1, so that'll be minus 220, and then 20 squared is 400. So we're going to get negative 140 over 400. And to simplify this fraction, we can divide the top and bottom by their greatest common factor, which is 20, and we get negative 7 over 20. Now you can leave your answer like this. I like to put units at the end just for the sake of completeness. Since the base is in centimeters, dB dt, the rate of change of the base, will be in centimeters per minute. And finally, step 7, double check your answer. This question was asking for the rate of change of the base, so dB dt. And since the negative number, this signifies that the base is decreasing. Just as a note, a common mistake I see, the wording of the question, if it instead it asked for the rate at which the base is decreasing, we would give a positive number since it would be decreasing at a positive rate. But since it just says changing, our answer is negative 7 over 20.